right, welcome to Chapter 2, Part 3. We're continuing to work with lines. We are going to review what slope is. We're going to look at a new form called point slope form, and then we're going to review standard form and look at applications, and we are going to wrap up talking about parallel and perpendicular lines. So first, let's remember about slope. So slope, remember, was how steep a line is. We calculate it by using rise over run. Rise is the change in y, and we can denote that with a delta, or that little triangle sign. Delta stands for change, so change in y divided by change in x, which is the run. And we can calculate it by finding the distance between the two y values and the distance between the two x values, which means that we need 2 points in order to find slope, okay? We can take that slope and we can use it along with the y-intercept. That's important for this to be the y-intercept in order to find slope-intercept form. So what if we have 2 points, but neither one is the y-intercept? So if we have 2 points, such as 1, 4, and 2, 7, okay, those are 2 points. How can we find the equation of the line? Well, we know we can find the slope, but how do we find the y-intercept? Or is there another way that we can use in order to find that equation of the slope? And that's what we're gonna look at next. So we're not gonna find it for those 2 points. We are instead going to look at first the general formula, and then we'll apply it to a different pair of points. So we're going to start out by defining the point slope form is when I do not have the y-intercept. If I have a y-intercept, I'm going to use slope-intercept form. That's much easier. There are fewer steps. I just need the slope and the y-intercept, and then I'm done. For point slope form, if I don't have the y-intercept, then first I need to identify the slope. If I'm given a slope, great. If I'm not given a slope, I have to calculate it, right? And then we're going to substitute that slope and 1 point. Now, it doesn't matter which point you choose, either point will work, and we'll look at an example, okay? And we're gonna substitute it into the equation, this last one here. Now, if you have trouble remembering this equation, as long as you remember the formula for slope, you can always remember this equation. Because in order to get point slope form, all we've really done is we've multiplied the denominator to both sides so that it cancels on the first side. And then we've just rewritten it without the 2's. So really, this formula is the same as the formula for slope, okay? Just rewritten, a little bit reimagined. And then once we have that point slope form and we substitute into it, we want to solve for y equals something, and we'll get a form y equals mx plus b in the end, okay? So point slope form is just a method in order to find an equation of a line, and that equation can still be written in slope-intercept form. So they're not completely different, they work together. Okay, let's take a look at an example. A line passes through the point -5, 2 with a slope of 3/5. What is the equation of the line? Well, our first temptation is to use slope-intercept form, right? If I say y equals mx plus b, I already know part of what I need, right? I need the slope, and we're given the slope, m equals 3/5. But I would also need b, and I don't have the y-intercept. So instead, what we're going to do is we're going to use our new formula. Our new formula is y minus y1 equals m times x minus x1. Okay, so what do I need to do with this equation? X comes first, y comes second. So these are going to be my x1, y1. Now I only have 1 point, so I don't really need to put subscripts on here, but that tells me which variable I'll be replacing. So y minus y1 is 2, always replace in parentheses, equals m, that's 3/5, times x minus -5. And this shows why it's so important to replace in parentheses, because that minus a negative becomes a plus. So now we have y minus 2 equals 3/5 times x plus 5. Okay, then we have y minus 2 equals 3/5 x plus 3/5 times 5, or 5/1, is 3. Add 2 to both sides, plus 2 plus 2. Let me continue over here. We have y equals 3/5 x plus 5. So notice this is our final answer in slope-intercept form. So our answer can be in slope-intercept form, but the way that we found that is by using the point-slope formula. So we use the formula where we can substitute in a point and a slope, and then our answer tells us, oh, our y-intercept has a b value of 5. I didn't know that from the given information, but now that I've solved it, now I can know that. Okay, let's do another example. So in that example, we were given a slope. This time we're given 2 points. A line passes through the points 3, 2, and 5, 8. What's the equation of the line? And we want to write that equation in point slope form. Okay, so what does that mean to write it in point slope form, right? In our last example, we wrote it in slope intercept form. Well, that just means we don't have to do that last step where we solve. We just have to substitute and simplify, and we don't have to solve. What does that mean? Well, let's do it together. Okay, so we want to find the line that passes through these 2 points. We need a slope. Every time we're finding a line, we need a slope. So how do I find the slope? That's going to be y2 minus y1 divided by x2 minus x1. So I'm going to call this point 1. There's my x and there's my y. This one's point 2. There's my x and there's my y. Again, it doesn't matter which one you call 1 and 2. We'll get the same answer. So starting with my y's, 8 minus 2 divided by, now my x's, 5 minus 3. 8 minus 2 is 6. 5 minus 3 is 2. That reduces to 3. Okay, so we have a slope of 3. And then I need to pick a point. Which point? Doesn't matter, either point. Okay, so we're going to substitute it into our new formula. Y minus y1 equals m times x minus x1. Let's pick the first point. Why not, right? Y minus 2 equals 3 times x minus 3. That's it. We are done. Okay? Alternately, I could have chosen to use the second point, right? So again, the subscripts just tell us which point we're talking about. So even though it's labeled as x2 and y2, I can still choose to use that point. Y minus my y value of 8 equals 3 times x minus 5. Also a valid answer. Okay, now why can I have 2 different equations here? Because if I were to solve for y, these 2 equations would give me exactly the same answer. Okay, if you try solving for y, you will get exactly the same answer for both equations. Let's do another example. Oh, not another example, that comes later. First, we want to look at, okay, so we've talked about 2 forms. We've also introduced a 3rd form without really talking about it, so let's summarize them. Okay, so we have slope-intercept form. That tends to be our favorite, y equals mx plus b. This is a way that we can write our equation. We can also use it to solve for an equation if we have the y-intercept. We always need the y-intercept in order to solve the equation into slope-intercept form. Okay, if we aren't given the y-intercept, then we can use point slope form. That's the one we just did, okay? If we're given a slope and a point, or if we're given 2 points, we can use point slope form. So this is slope and y-int, or instead of slope, or another point. This one is 2 points, not the y-intercept, or slope and point. So essentially, if I have the y-intercept, I use the first one. If I don't have the y-intercept, I use the second one. So what is this third one? Well, standard form is essentially rewriting it so that all of my variables are on one side. Why is that helpful? Well, in standard form, it's a little bit easier to find your intercepts. So we've talked about the y-intercept, where the line crosses the y-axis, but we can also have an x-intercept, where the line crosses the x-axis. Okay, so standard form is useful if I wanted to find both intercepts. It makes it a little bit easier to do. So let's look at that. If I want to use the standard form of this equation, what I have to do is I have to get both variables on the same side of the equal sign. So here I have a y, here I have an x. I want them to both be on the same side of the equal sign. But I also don't want to have any fractions. I want just integers. So do we remember, how do we get rid of fractions? How do we make an equation and take it and have no fractions afterwards? We have to clear the fractions. Clear the fractions. And the way we do that is by multiplying by the denominator. Okay, so what's our denominator here? 4. I want to multiply everything by 4. So y equals 3/4 x minus 5. Multiply everything by 4. That means every single term. So now we have 4y equals, the 4 cancels, 3x minus 20. Every single thing got multiplied by 4. Every term. Every time there was a sign that was plus or minus or equals gets multiplied by 4. And now I want the x and y to be on the same side of the equal sign. So let's minus 3x, negative 3x plus 4y equals negative 20. Now that's okay because it just says to use integer coefficients. However, it kind of feels weird to leave a negative out in front of your equation, right? So if you wanted to be particularly clever, you can divide everything or multiply everything by -1, and that'll just make it a little bit nicer. 3x minus 4y equals positive 20. It's just nicer not to have as many negatives, and especially not to have a negative out front. Okay, both answers are acceptable for this question. This is proper, and this is acceptable. All right, let's take a look at our next one. Now we want to, remember how I said it's useful for finding the intercepts? Well, I put a little reminder up in the top left corner about what intercepts are. So how do we find an intercept? Well, that's where the line crosses our axis. And what does the axis represent? Well, let's think about our y-axis, right? Our y-intercepts are on the y-axis because they have an x value of 0. So we can say the same thing for the x-axis. All of the points on the x-axis have a y value of 0. And that's how we're going to solve these points. Let's start with finding the y-intercept. In order to find the y-intercept, we want to set x equal to 0. Because all I want is a y value. The y-intercept is a y value only. And so we have 3 times 0 plus 5y equals 15. 3 times 0 goes away, that's just 0. Divide both sides by 5, y equals 3. So there's our y-intercept. Okay, we also want to find the x-intercept. To find the x-intercept, we want to set now y equal to 0 because I only want to be left with an x value. So we have 3x plus 5 times 0 equals 15. Well, 5 times 0 is nothing. So now I want to divide both sides by 3, and x equals 5. Okay, and then we want to draw the line between those 2 points. I'm going to draw it as neatly as I can. There we go. And if we wanted to find the equation of this line in slope-intercept form, for example, we can either take our original equation and solve for y, or now that we have the y-intercept as 3, that's our b value, right? We can also find the slope, 3 over -5, y equals rise over run times x plus b. So that's our other way that we can write our equation. Standard form, and slope intercept form. Let's take a look at our next one. So now we're going to apply this. The number of times a cricket chirps per minute depends on the temperature. The number of chirps in 2 seconds for the 2 temperatures are given to the bottom right. So that's down here. So 2 seconds, but we want chirps per minute. So how many times do I have to count to 2 seconds before I get to a minute? How many 2-second intervals are there in a minute? Well, a minute is 60 seconds. So I have to multiply these by 30, right, to get to a full minute. So at 40 degrees, how many chirps were there? 0 chirps. 0 times 30 equals 0, right? At 93 degrees, we have 8 chirps. 8 times 30 equals 240. Okay. All right, so these are actually 2 points. We have 40, 0, and we have 93, 240. So we're going to try and graph this. Now, my graph that I have on here is 10 by 10. So I'm not going to count by ones, right? But maybe I can count by tens. So if this is 10, 20, just like we were doing the number lines for the project. So that's 20, 30, 40. 40, 0 is right here. And then my y-axis, I can't count by tens. I have to get up to at least 240. So I'm going to go by 25s. 25, 50, then that makes this 75, 100, 125, 150, 175, 200, 225, 250. Okay, so now I want to go out to 93 degrees. So that's 20, 30, 40, 50, 60, 70, 80, 93 degrees is somewhere around here. 93 degrees, and up to 240 is just below 250. So there's about my point. I want to connect those to make our line. Okay, so there's my line. There's my graph, okay? So how do I find the equation of that graph? Well, we have 2 points. Let's find the equation between them. So always starting, we need a slope. So y2 minus y1, let's call this y2, y1, that makes this x2 and x1. y2 minus y1 over x2 minus x1. That's 240 minus 0 divided by 93 minus 40. That gives me 240 divided by 53. And then we would want to check, does that simplify? So if I check that in my calculator, 240 divided by 53, and we'll go ahead and round that, is approximately 4.5. Okay, there's my slope. What else do I need in order to solve the equation of a line? Well, I have a slope. Do I have a y-intercept? No, I have an x-intercept. Be careful of that, right? I have an x value, so that tells me that's an x-intercept. An x-intercept, I can't use slope-intercept form. I have to use point slope form. So y minus y1 equals m times x minus x1. Y minus y1 is 0. Ooh, we like that. Equals 4.5 times x minus 40. Y equals 4.5x minus 4.5 times 40 gives us 180. Okay, so there's my equation, but we want it in standard form, right? So what is standard form? X and Y have to be on the same side of the equal sign. So minus 4.5x minus 4.5x, we get negative 4.5x plus y equals negative 180. Now remember that thing that I mentioned about the negatives being out front? Let's go ahead and switch all of our signs so that we don't have that negative hanging out front. It's not wrong to leave it like this. It's just not pretty. So I'm gonna change all of my signs, plus, minus, plus. We get 4.5x minus y equals 180. This time it didn't say to leave our coefficients as integers, so we can leave them this way. So this was part A. This is part B. And lastly, part C, if the temperature is 70 degrees, how many times would a cricket expect to chirp in 1 minute? So I'm going to change colors here for part C. Now that we have our equation, we can go ahead and substitute in our information. So what variable does the 70 represent? Well, our temperature was our x's, so x equals 70. So now we're going to say 4.5 times 70 minus y equals 180. 4.5 times 70 gives us 315 minus y equals 180. Let's go ahead and minus 315 minus 315. Negative y equals negative 135. Divide by negative 1, so we're just changing the signs again. Y equals 135 chirps. So at 70 degrees, we would expect the cricket to chirp 135 times per minute. Ooh, that's a lot. All right. Our last topic for tonight is parallel and perpendicular lines. So when lines are parallel, parallel means they never touch, right? Remember this from algebra and or from geometry rather. Parallel lines never touch. So if we have two lines that are parallel, that means that their slopes are exactly the same and their y-intercepts are different, because if they had the same y-intercept, they would overlap completely. They would be the same line. So two parallel lines have the same slope, m1 equals m2. The two slopes are equal, but the y-intercepts are not the same. They're not equal. Okay, our other type of relationship between lines is perpendicular. If I have two perpendicular lines, that means they make a 90-degree angle. And so the two slopes are not equal this time, and they're not even just opposites of each other. If we think about a slope of 2 and a slope of negative 2, those are not going to create a right angle. However, a slope of 2 and a slope of negative, it has to be negative, it has to be pointing the opposite direction, but it also has to be the opposite steepness. So a slope of 2 and a slope of 1/2 are perpendicular. Sorry, negative 1/2 are perpendicular. So the way that we can tell when two lines are perpendicular, their slopes multiply to -1. That's the first way. The second way is to say they are opposite reciprocals or negative reciprocals of each other. So 2 to 1/2, but also one is positive and one is negative. 3 to 1/3, but one is positive and one is negative. 7 to 1/7, but one is positive and one is negative. So if I have that last example, I said 7 times -1/7, that gives us a product, multiply them together to get -1. So the way that we can check when two lines are perpendicular, if we multiply their slopes, the product should be -1 to say that those two lines are perpendicular. So let's see if we can find some equations. We want to find the equation of a line in slope-intercept form for the line parallel to y equals 6x minus 2, but going through the point 1 comma -3. Okay, so we have a lot of information going on here. The first thing is we need to find the equation of a line, right? And what do we always need in order to find the equation of a line? We always, 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 always need slope. Okay, so how do I find the slope? I wasn't given the slope. I also only have 1 point. So how do I find the slope? Well, we're going to get the slope from this phrase right here. It's parallel to this line. That means it has the same slope as the given line. So what is the slope of our line that was given? Well, y equals mx plus b, right? So the slope is 6. The slope that we need for our line is a slope of 6. We also wanted to go through this given point. Is that point a y-intercept? No, our x value is not 0, so that's not a y-intercept, and therefore we need to use point slope form. Good. Okay, so y minus y1 equals m times x minus x1. Y minus -3 equals 6 times x minus 1. All right, so now we're solving. Minus a negative is plus equals, distribute the 6x minus 6, minus 3, minus 3. Let me just double check. Slope-intercept form is the slope and the intercept. I'm getting the right form. I want the one with the b. So that's y equals 6x minus 9. Okay, our next one, we want to look at a line that is perpendicular. Perpendicular. So again, I need to identify the slope. Y equals mx plus b. The given slope is -4. We want the opposite reciprocal slope. So what slope do we want? If the slope that we have is -4, the opposite of that would be a +4, and the reciprocal of +4 is 1/4. So -4 becomes +1/4. That's the slope we're going to use. Through the point 8, 5. Is that a y-intercept? No, because my x value is not 0. That is not a y-intercept. So we're using our point slope form again. Y minus y1 equals m times x minus x1. Y minus 5 equals 1/4 times x minus 8 by substitution. Y minus 5 equals, distribute that 1/4, 1/4 x, it's 8/1, right? 1/4 times 8/1, let me do it off to the side, 1/4 times -8/1. 4 and 8 reduce, so this is -2. Plus 5, plus 5, y equals 1/4 x, -2 plus 5 is +3. Okay, so the last problem on this on our next slide is going to be homework. It's this exact same process with different lines and points, okay? So this is for homework. What is the equation of each line in slope-intercept form? It's exactly the same process that we just went through. One of them is parallel, one of them is perpendicular. And then the second part of your homework is to do the lesson check, all 9 problems. Okay, now why is it so many problems? Because there's a couple things. First of all, this is super, super important. We need to know how to find the equations of lines, how to manipulate the equations of lines, but also it should be pretty quick. Okay, so using that slope intercept form and point slope form, we want to get really used to it so that it's easy, that it's second nature, because we are going to use this equation of lines all the time. And then we're going to start using harder equations, equations with different variables and different exponents, so quadratic equations and things like that. So I really want us to have a really solid understanding of lines as we're going forward. Okay, so make sure you plan accordingly. I mentioned it in class. I said it was going to take a little bit longer to do the practice this time. So hopefully you planned accordingly. If you have any questions, always, always, always feel free to email me. And I'll see you in class.